Hello and welcome. So today we're going to talk about a technique for integrating, and it's called the integration by substitution. Now, with the fundamental theorem of calculus, it gave us a way to integrate without having to use the Riemann sums. But we have to know what the antiderivative is, and sometimes that's not easy to do. Okay, so today we're going to talk about a technique for making things simpler to find what the antiderivative is. Okay, especially when we have more complicated looking functions or situations. So one of the other things too that I want to mention is that this technique is more of a visual technique, so you have to know what you're looking for, okay? And it's really used, this substitution, integration by substitution is used when you see something that is a result of the derivative using the chain rule, okay? So that's really where this thing comes in, okay? And so that's what we're going to be looking at. That's why I said it's visual. You're looking for an inside function and outside function so we can do a substitution, or what we call a change of variables. We're going to change the variables so that it makes it easier to see how we're going to integrate this thing and what the antiderivative looks like. Okay. For example, if I give you something like this, okay, and we want to integrate this thing. Well, we notice that we have an inside function, so we have a composition of functions here, right? So we could say that f of x is equal to the outside function, right? So that I would say that that's going to be x cubed, right? And so then the inside function g of x, which is right here, is going to be x squared minus 3. And then you also notice that this piece here is the derivative of this piece. So we can say g prime of x is equal to 2x dx, or actually just 2x. We'll get to that. Dx. Okay. And so now we can rewrite this as the integral, oops, right, if we look at it this way, we can do it as the integral of f of g of x times g prime of x dx. And then we can see that our integrand is in the correct form. Okay? And then we can do a change of variables. We could do a u substitution. Okay? And that's why we call it substitution, because we're going to substitute in for different variables so that we can see the form a lot better, and then we can easily, or more easily I should say, integrate. And then once we integrate, then we're going to move things back to the original variable, right? So if we do a substitution or a change of variables, in the end, we're going to want to change back to the original variable. Now, sometimes we don't have to do that, but we'll cover something like that later. But that's it. So this is use substitution in a nutshell. And then next time, in the next video, I'm going to go through the theorem and I'll do the proof of the theorem. Okay. Have a good day.